Hey folks, software is most useful when it's reusable and extensible. If I have a program that allows me to easily write my own customizations and extensions for it, that benefits not only me, but everyone else who uses the program, since they can leverage my efforts. Today, I'm going to take a look at a software library that aims to be a universal system for allowing programs to be extended by way of WebAssembly. It's called Extism. The idea behind Extism is this. You can write a program that uses the Extism library to accept extensions written in WebAssembly. Your host program can be written in one of a whole slew of popular languages, and you can use most any language that compiles to WebAssembly to write your extensions. Extism development has two big components, the host SDK and the plugin development kit, or PDK. The host SDK is basically a library you import into the program you want to add extensibility to, and it provides you with the tools you need to talk to Extism extensions. The PDK is used to write those extensions. It's only available for a subset of languages that compile to WebAssembly. The PDK itself is written in Rust and exposes C-style interfaces, but you don't have to use Rust to create your plugins. You can write JavaScript or AssemblyScript if you just want to do things quickly. So let's take a look at a simple example of Extism in action. And again, you have a broad choice of languages to write apps that use Extism, but I'm going to be using Python here for the sake of simplicity. Now here I've set up an environment with the Extism Python library installed, which includes a mini runtime for WebAssembly. We don't need to install our own runtime, it comes included. The Python program I've written, adopted from an example in Extism's documentation, uses an Extism sample plugin called count vowels, and that does just what the name implies. It takes in a string, and it returns a JSON response, a standard way for Extism plugins to receive and return data. And in Python, we can easily translate that JSON string into a dictionary, or vice versa. To use the Extism library in Python, we have to first define a manifest for the plugin. This is a set of structured data that tells us where to find the plugin and some other details about it if we need them. So here, our manifest just provides a path to the plugin on disk. Now we could even provide the plugin in the form of a binary stream in the manifest, or we could supply a URL to load it from, but a file on disk is the simple way. Now once we create the plugin binding, we can use the call method to invoke an exposed function in the plugin, in this case it's count vowels, and we pass in some data. The result comes back as a JSON string, and we can use Python's JSON library to further process that. Note that if we wanted to return data as nothing more than a string, we could do that, but using JSON lets us return more complex structures. Now to get an idea of how a plugin can be written, let's take a look at another simple example in AssemblyScript. This example takes in a name as a string and returns a hello message using the string. The Extism library, through the host object, handles formatting the input and output data as strings, and it lets us do whatever we want in the interim. Note that the actual return value of this function is an error code. It's not the output data. That's handled from and to the client using the host object. Now, I've already compiled this extension to WebAssembly, and I have here another program in Python that uses it. It's far simpler since we're not using JSON to format this data. We're just using strings in binary format. So when we run this, we get back a simple binary string. Now, when you write your own programs, the idea will be that you can expose interfaces in your app, and your app can discover and add plugins that can hook into these interfaces. Another advantage to using WebAssembly as a runtime for those plugins is that WebAssembly gives you some native execution protection for the code. You don't have to worry as much about the security implications that might come from, say, embedding a Python or a Lua interpreter into your app. So if you're curious about creating apps that have extensibility as a feature, and you're looking at WebAssembly as a platform for adding that extensibility, or you're just curious about how WebAssembly could be made part of an application in general, it's worth giving Extism a look. That's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.